Hi everyone, welcome back. Today is Wednesday and I'm going to go over how to start our new unit today. This is coordinate geometry proofs. So to put your mind at ease, first of all, this is not the kind of proofs that we did earlier this year. This is not statements and reasons. These proofs are actually just a way for you to show your work and then write a couple of sentences to summarize your work. Most people like these better than the other proofs that we did. And I'm going to try to keep these as simple as possible for you as we go through. So here goes. Today's date, I'm going to date this lesson for 3/25/2020. And we are going to start with the most basic figure, which is proving that something is a parallelogram. So you probably remember a lot of different facts about parallelograms when we learned about them earlier this year. When we need to prove or show that something is a parallelogram when we're on a set of coordinate axes, we have to show one of those things that you already know. In other words, we have to show that both pairs of opposite sides are congruent or that both pairs of opposite sides are parallel. The nice thing about this is that you have several choices. So you'll notice this chart at the beginning of the lesson. These are choices. You do not have to do all of these by any stretch of the imagination. You would pick one, whatever one you like the best, and that's what you would do. So I'm going to go over your options, and then I'm going to show you one or two proofs totally worked out. So for the first option, if you like the distance formula, then you can use the distance formula 4 times to prove that something is a parallelogram. In order to do that, what you would need to do is you would want to show me that both pairs of opposite sides are congruent. That would be option 1. Now, maybe you don't really love distance formula and you'd rather use slope, especially because with slope you can just count if you graph it first. So fine, if you would rather talk about slope, you would have to find slope 4 times. And then instead of showing me that both pairs of opposite sides are congruent, your option here would be to show me that both pairs of opposite sides are parallel. And in case anybody needs a little extra reminder on this, you would show me that both pairs of opposite sides are congruent by showing me that they have the same length using that formula. And on this one, if you're showing me both pairs of opposite sides are parallel, then you'd be telling me that they have the same slope. So it's an or kind of situation, guys. You don't have to do both of these things. You do one or the other. Now, there are still another couple of options besides that, but I have to tell you that these two are my favorites. They're the ones that most people gravitate towards. But for another option, if you like the midpoint formula, the nice thing about using midpoint formula here is that you only have to do it 2 times instead of doing 4 things like the others require. And what we would do here is we'd be showing that diagonals bisect each other. And the way that you do that with midpoint formula is just to show me that both diagonals have the same midpoint. And then we're up to our last option. Last option, really not my favorite, but just in case you're interested, that is if you'd rather have a little bit of a variety. You could do distance and slope and do them 2 times each. So you would do 2 distance and 2 slope. The important thing if you want to do this one is you have to make sure you're finding the distance and the slope of one pair of opposite sides. You pick a pair of opposite sides and you stick with it. So what you'd be showing here is that one pair of opposite sides are parallel and congruent. And of course that would be parallel because they have the same slope. congruent because they have the same length. So I'm going to reiterate here. You don't have to study all of these. You don't have to know all of these. You basically need to know one of them. So if there is a particular formula that you would prefer to use, you can just use that method most of the time. What I'm going to try to do with today's lesson is I'm going to try to show you these different options. I'm going to do the first problem with the distance option. I'm going to do the second problem with the slope, and I'm going to do the third problem with the midpoint so that you can see what the work would look like for each of those and what the wording on the sentences that you write at the end would have to look like. You have a choice when it comes to doing these problems on, say, the Regents exam. You would most probably get to pick which one you would rather use to prove what they're asking you to prove. So if you want to shut this off and go ahead and then come back to check later, you certainly can. The work that I'm going to be showing, like I said, I'm going to do the first one by distance. I'm going to do the second one by slope. I'm going to do the third one by midpoint, just so you can see one of each. Okay, so starting with example number 1, they tell us about quadrilateral PQRS. So they're just telling us that it has 4 sides right now. We are supposed to prove that this thing is a parallelogram. So we're going to start by drawing our picture because that gives us something to work off of. So P is the point 0, 3. Q is the point 4, 2. R is the point 5, -4, and S is the point 1, -3. Especially on a test or a quiz, I would recommend that you use a ruler. I know you're working at home right now. You might not have a ruler around to use, but it does make the picture more accurate if you use a ruler also, which makes it a little easier to see what I'm talking about sometimes. So my advice, use a ruler or the side of a book or something, side of your calculator. So there's my parallelogram. I also recommend that you write in your 1 box equals 1 unit, and you make sure that you label your axes, x-axis, y-axis. That is definitely something you don't want to forget on a big test. All right, so work. Like I said to you, I'm going to do this one by distance formula. So first thing I'm going to do is write down my distance formula. Distance formula, of course, is the square root of x2 minus x1 squared plus y2 minus y1 squared. And now I'm going to need to find the length of each side. You can do these all at once and do all the writing at the end, or you could do them 2 at a time and do a little writing as you go. It's up to you. I'm going to start with side PQ as my first side here. So side PQ, if I'm looking for the length of PQ, remember I don't have to write a segment over it. I can just write it like that. This means the length of PQ. And now I'm going to plug in those numbers right into my distance formula. So I am going to have 4 minus 0 squared, and then I'm going to have 2 minus 3 squared. You can use your calculator for this. I would encourage that. You end up here with the square root of 4 squared and -1 squared, which is a grand total of the square root of 17. Now, I'm hoping that my side across from PQ will have the same length. So that's the one I'm going to do next. I'm going to find the length of RS or SR. So when I go ahead and plug in for that side, S and R, I'm going back to these numbers. I'm going to have 1 minus 5 squared and -3 minus -4 squared. Watch those double negatives. They tend to trick people. We end up here with the square root of -4 squared, and here we end up with just plain old 1 squared. So again, we end up with the square root of 17. Now that's what we wanted to have happen. We want to show here that both pairs of opposite sides are congruent. This showed that one pair of opposite sides is congruent. So I can actually say that as a sentence here now. PQ is congruent to SR. Those sides are congruent because they have the same length. And I think many of you will be happy to know that's what I mean by proof. You're showing the proof. You're doing the work and then writing a sentence. So that's the first part of this proof. Now I also have to show that the other pair of opposite sides has the same length. So I've got to find both of those sides. I already wrote down my formula. I don't have to do that again. I have to go figure out how long PS is, and then I'm going to have to figure out how long QR is. So using the coordinates from P and S, I'm pointing to something you can no longer see here. There we go, P and S. I'm going to go ahead and plug in my numbers here. And so I end up with 1 minus 0 squared plus -3 minus 3 squared. That ends up giving me the square root of 1 squared plus -6 squared, which means it's the square root of 37. Okay, that doesn't match the other two, but it's not supposed to. That's okay. Look at the picture. You can tell almost that this is going to be a different number than the last one was. And now I'm going to go do the same thing with the side opposite from PS. So opposite from PS, we have QR. I'm going to go figure out how long QR is now. So plugging in Q and R, I'm going to have something like 5 minus 4 squared plus -4 minus 2 squared. That means I have 1 squared, and again I have -6 squared. That means again I should end up here with the square root of 37. Wonderful. Now they match. You have to say that. You have to tell me that. Now I'm going to have to move this up. There we go. PS, side PS, is congruent to side QR because, same reason that I used up there, they have the same length. And now finally I have to finish my proof. I was asked to prove that this thing is a parallelogram. Well, I just proved, I showed it, and then I wrote a sentence. I just proved that both pairs of opposite sides are congruent. So since both pairs of opposite sides are congruent, I'm now allowed to call this a parallelogram. I can finish this up by saying PQRS is a parallelogram because both pairs of opposite sides are congruent. So we do the work to show it, and then we wrap it up with a sentence. That is what a coordinate geometry proof looks like. In my personal opinion, this is easier than the proofs that we did earlier this year. It does depend on the person, but I think most of you would probably agree with me on that. Probably the hardest thing for people to get used to is writing these sentences. So I'm going to underline them for you here. This sentence tells me one pair of opposite sides is congruent. This sentence tells me another pair of opposite sides are congruent. And this sentence concludes what they wanted me to say, which was that the figure is a parallelogram. You have to show your arithmetic and write the sentences. Those two pieces together give you full credit for the problem. So that's the first problem. Great. And now it's time to move on to problem number 2. So for our second problem here, we are going to prove that this parallelogram, or that this figure rather, is a parallelogram. Now this figure I don't like so much. You're probably not going to like it as much either. And the reason why is because I don't have points. I have letters instead of points. When a problem looks like this, my advice to you is actually not to use the graph. I'm not going to use the graph. I'm just going to draw a quadrilateral named ABCD that looks like a parallelogram, just so that I have something to refer to keep track of which sides are across from each other. So I'm going to ignore my grid. The grid is always optional on these problems. And I am just over on the side going to draw a figure and use the rules that we've talked about many, many, many times, which is if you start at one corner labeling it A, you have to go around in a circle, A, B, C, D. You can't zigzag. It has to go around in one direction. This is only so that I can look at this figure and say, okay, well, that means that AB and CD are across from each other. And it also means that BC and AD are across from each other. So, as promised earlier, I showed you how to do the first problem using the distance formula. I'm going to show you how to use this problem using the slope formula. So the first thing that we would do here is we would write down the slope formula. The slope formula, of course, is that my slope equals y2 minus y1 over x2 minus x1. And what I need to do here is I need to find the slopes of all the sides. I'm going to start with two that I can see are across from each other, AB and CD. So if I go over to side AB and I want to find my slope, I'm going to plug those coordinates from A and B into the slope formula. That means x2 minus x1 over y2 minus y1. That means my slope of line segment AB is actually little a over little b. Now I'm going to have to do the same thing for the opposite side, which is side CD. So for side CD, if I'd like to find the slope, a little bit more annoying looking, but that's okay. I'm going to have C minus C plus A, and that goes over 0. Oops, I just made a mistake, didn't I? I just put the X's on top. I'm sorry. I'm just going to erase that. It's a good thing I'm prepared for these kinds of mistakes. Change in Y over change in X. Okay, so 0 minus B, sorry about that, over the change in X, which would be C minus C plus A. So when I go to simplify that, I'll have a negative B on the top. And on the bottom, just be careful with your distributive property there. That means you have C minus A, which means I have negative B over negative A, because these cross out, leaving me with B over A, making me go back and look at what I did for AB, and I'm sure you've all realized this already. I had a mistake there. For some reason, I accidentally put the X's on top. I guess my mind is not quite where I'd like it to be today. We're going to fix that up now as well. I'm really sorry about that mistake. So here goes. Change in Y, people. Remember, Y is the second coordinate, so the second part of the coordinate. So B minus 0 over A minus 0, that should be B over A. Now they match. Now, I'd love to pretend that what I just did was on purpose, but it is something that some of you might actually do, and that is you're in mid-problem, and you know these two things are supposed to have the same slope, but your work doesn't show that. Well, if your work doesn't show that at first, you must have made a mistake in one spot or the other, so you have to go back and check. So I went back and checked. I accidentally was putting my X's on top. I don't know why. Silly mistake. We all make them at home. Maybe I'm a little more distracted than when I'm at school. So they should both work out to be B over A. That means, as my sentence here, I could now say that AB is parallel to CD because they have the same slope. So you notice that your argument here is a little bit different. In the last problem, we were saying, look, they match, so they're congruent. Here we're saying, look, they have the same slope, so they're parallel. Your argument has to match your work. So this work is telling me about things being parallel or not. Now I have to go and do that with the other pair of opposite sides. So I am now going to go to side BC and find that slope. I'm going to try to be a little more careful here about putting things in the right places. So for BC, I'm going to have change in Y, which will be B minus B, over change in X, which will be C plus A minus A. Well, this does something interesting. I get 0 over C, which is 0. 0 divided by anything is 0. That's okay. Now I'm going to see if I can get AD to match that. So using my coordinates for AD, when I go to find that slope, I will be looking at change in Y, so 0 minus 0 over change in X, so C minus 0, which means I have 0 over C, which again is 0. So again, I have matches the way I'm supposed to with my change in Y over my change in X. That means I can now say that BC is parallel to AD. And my reason for that is because they have the same slope. This allows us to conclude our problem with a different argument than problem 1. Our argument here is that both pairs of opposite sides are parallel because that's what we showed. Our work and our argument have to match each other. So I can now say that ABCD is a parallelogram because both pairs of opposite sides are parallel. So I'm going to point out what I did back in the first problem. You need to have these sentences. You have to tell me about the first pair of opposite sides having the same slope. You have to tell me about the second pair of opposite sides having the same slope. And then you need to conclude by telling me it is a parallelogram because you showed this other stuff. So that is a nice fully developed proof. And then we're going to go and take a look at number 3. Our last problem for today on the lesson is about how to prove that something is a parallelogram. So to prove something is a parallelogram with another option, I'm going to go with the third one on our chart from the first page, which is using midpoint formula. So I'm going to graph this because I can see that I'm back to having normal number coordinates. So I'm going to make my x and my y axes clear. I'm going to write 1 box equals 1 unit. And now I'm going to get to work. So O is the point 0, 0. N is the point 6, 3. L is the point 9, -1. And Y is the point 3, -4. And so when I go ahead here and graph this, if I want to show that the midpoints are the same, I'm talking about the midpoints of the diagonals being the same. So I'm going to be worried about my distance, my segment rather, that goes from O to L. And I will be worried about my segment that goes from N to Y. Now, unfortunately on this picture, that doesn't look like a nice coordinate. It's going to be some kind of weird number, but that's okay because I'm just going to use my midpoint formula and it should show me that I get the same point both times. So my midpoint formula for review is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. And when I go ahead and look at one diagonal at a time, I'm going to start with OL. When I want the midpoint of OL, I will be looking for the sum of O and L. So 0 plus 9 divided by 2 for the x part. And for the y part, that would be 0 plus -1 that I'm dividing by 2. That means when I plug this in the calculator and I simplify, I'm going to get 9 over 2, which is 4.5 or 4.5, and -1 over 2 or -0.5. That's my coordinates for the midpoint of OL. Now I'm hoping when I go and look at the other diagonal that that midpoint will be the same point. Only way to know is to try. So I'm going to go back to my N and my Y. And plugging in those values, I will have 6 plus 3 divided by 2. And for the y values, I will have 3 plus -4 divided by 2. And sure enough, when I complete that arithmetic, I am again going to end up with 9 over 2, or 4.5. And I'm again going to end up with -1/2. And if you've made the graph, you can use it as a way to kind of double check yourself. 1, 2, 3, 4, and about 1/2, and down about 1/2. That seems just about accurate. So the nice thing, besides the fact that midpoint is a little bit less arithmetic, is it's also a little bit less writing. What we have to do here is declare that these have bisected each other. So we can say that OL and NY bisect each other because, how do I know this? Because they have the same midpoint. And then I can say that only is a parallelogram because the diagonals bisect each other. So, like the other two proofs that we've looked at so far today, the work consists of really two parts. It's whatever arithmetic you decide to do, and then some sentences explaining what that arithmetic is really showing. So our first sentence here says, look, they bisect each other because they have the same midpoint. And then my second sentence here says, look, it's a parallelogram because the diagonals bisect each other. So that's the way these work. In most cases on a standardized test, you will have a choice as to which one you would rather, which method you would like to use. You'll see the homework tonight is not all proof. Some of it's just a little bit of arithmetic, and then some of it is actually doing a proof or two like this. So I hope that was helpful. Let me know if you have any questions, and have a great day. Bye.